Welcome back, Focus learners. Okay, so today we're diving into a genuinely fascinating and honestly pretty radical set of source materials. In this explainer, we're going to take a wild journey. We're starting with something that seems super mundane, earthly ecological problems, specifically seaweed, and we're going to zoom all the way out to a fundamental rethinking of the actual laws of the universe. We're looking at a perspective that links how we solve local crises right to the very fabric of existence itself. It's a massive shift in perspective, so let's just jump right in. Okay, let's dive into this roadmap. First, we're covering the crisis of knowledge, then the end of reductionism, the NCS framework, the small bang theory and cosmic limits, and finally, eternal emergence. As you'll see, starting with seaweed is actually going to unlock a vast theoretical framework of, well, everything.
So, Part 1, the crisis of knowledge and systemic opportunism.
The source material kicks things off by arguing that modern institutions often use this idea of academic humility as an opportunistic shield, basically hiding behind claims of, oh, it's just too complex, to dodge hard truths and maintain systemic power. And the text points out that this creates two totally different mindsets. On one side, you have cognitive inertia. Think of this as the lazy mind, kind of lulled to sleep by systemic pink noise. It's this comfortable consensus where data is spoon-fed so smoothly that you don't even need critical thinking. But on the flip side, there's epistemic discipline. And this requires a ruthless commitment to the truth. It means you're actively hunting down contradictions and, this is key, you are totally willing to destroy your own certainties the second you're faced with hard facts. To make this really concrete, the source uses the Great Atlantic Sargassum Belt. Basically, this massive seaweed bloom. Now, the bureaucratic response usually just throws its hands up and labels it a complex ecological plague. But let's look at the hard numbers here. Fresh sargassum is like 80 to 90% water, and it leaves behind 15 to 40% corrosive ash. So just burning it for pure electricity, financially, that's a complete non-starter. But if we apply that epistemic discipline we just talked about, a totally clear solution pops up, the biorefinery solution. By combining energy generation with extracting rare earths from that ash, plus getting fertilizers and bioplastics out of it, the whole operation becomes highly profitable. The argument here is that systems just hide behind complexity instead of aggressively going after this viable, integrated approach.
Moving on to Part 2, the end of reductionism and why physics is stagnating.
So, zooming out from local seaweed ecology to the macro level of theoretical physics, the source makes a really bold claim. It argues that theoretical physics has literally been stuck in a rut since the 1930s, and the text points a finger at a very specific culprit, stating, the reductionist dogma ignores that macroscopic system properties are emergent. This is a massive, fundamental critique of the last century scientific method. It's basically saying, hey, we can't figure out the universe just by constantly smashing matter into smaller and smaller pieces, looking for quarks or strings, and just hoping to find some ultimate foundational building block.
Now, what's really interesting about this is the core conflict between these two paradigms. Reductionism tries to explain a system by breaking it all the way down into its fundamental, isolated parts. Emergence, though, says something entirely different. It's the principle that macroscopic properties don't even exist in the individual parts themselves. Instead, they arise solely from how those parts interact with each other. The source is arguing that our universe is fundamentally governed by emergence, meaning the whole search for that one ultimate isolated particle is basically an epistemological dead end.
Which brings us to Part 3, the NCS framework. Nothing, crust, something. The radical ontology.
All right, we're zooming all the way out now. This is the most radical framework the authors propose, an attempt to totally replace traditional materialist physics with a purely relational topology. Let's walk through the three foundational axioms of NCS logically. Step 1 is nothing. But wait, this isn't just an empty physical vacuum like you might picture. It's a state of absolute symmetry, complete homogeneity, and zero information. Then, step 2 is the crust. This isn't a physical wall or barrier. It's a virtual boundary operator. It essentially breaks that absolute symmetry of the nothing by drawing a topological boundary. And finally, step 3 is something. That is the emergent structure, what you and I perceive as matter or energy. So the absolute key takeaway here is that matter isn't actually a physical substance at all. It's simply a topological boundary, this crust, folding right out of the unstructured nothing. So if matter is really just boundaries, what actually happens when things interact? Well, the text highlights this core formula. Structure touches structure.
Think about it. Because the unstructured nothing is totally identical everywhere. Mathematically, it just cancels out. Because of that, there's no spooky action at a distance through empty space, and there's no magical exchange of subatomic particles either. In this specific framework, every single interaction in the universe is purely relational. It is literally just the direct friction of these boundaries or crusts touching one another.
Okay, part 4, SBT in cosmic limits, the catastrophic reboot. So how does all this highly abstract topological theory apply to the actual physical universe we see around us? Well, check out this number, 3%. According to the small bang theory outlined in the text, 3% represents the mind-boggling quantity of the Earth's total mass that was supposedly ejected from the Pacific equator in a massive catastrophic event to form our moon. To put that into perspective, that is roughly 2.4 times the mass of the entire moon today. Just a staggering amount of material.
The text lays out the multifactorial mechanics behind this event, and it wasn't just some simple asteroid collision. It describes a massive fracture of a 30-kilometer thick granite crust. This fracture was driven by a 7,000 bar pressure differential that violently expanded straight into the vacuum of space. And this was apparently aided by continuous gas explosions that acted almost like a giant rocket thruster, plus the extreme centrifugal force of an early Earth that was spinning so fast it completed a day in just 6 hours. This unimaginable ejection allegedly shifted the Earth's crust so dramatically that it separated the former poles at Yellowknife and Jack Hills, moving them all the way to their current positions. And this brilliantly illustrates how the physical realities of these two scenarios compare. Without a moon, Earth would just have pure solar tides and incredibly weak seasons, driven totally by its elliptical orbit. But with the moon, created by this catastrophic reboot, Earth suddenly gets a 22-degree axial tilt, extreme seasons, and powerful lunar tides. The point here is that the moon isn't just some isolated rock floating up there. Its specific relational geometry dictates our current planetary stability, our climate, and honestly, our very existence. Finally, Section 5, Eternal Emergence and the Limits of the System.
So, if the universe is just structure building upon structure endlessly, does it just go up and up forever? The source argues no. There are hard physical vertical limits to structure and emergence in the cosmos. To explain this, the text uses the concept of submoons, which are literally just moons orbiting other moons. Now, why are those virtually non-existent in our solar system? It all comes down to the tidal dynamic barrier. For a submoon to survive, it has to stay inside the main moon's Hill sphere so it doesn't just get yanked away by the host planet. But it also has to stay outside the Roche limit, otherwise the moon's gravity will literally shred it to pieces. Over time, tidal friction just destroys those delicate structures. This shows that hierarchical emergence has a hard limit. You can't just keep stacking structures infinitely like a giant cosmic Jenga tower. Eventually, the foundational forces destroy the smaller, deeper structures. Evolution is essentially forced to spread out horizontally rather than building vertically.
And this physical limit brings us to a really profound philosophical question posed by the text. Can a system ever fully explain itself? Think about it. If we are just emergent structures living inside an emergent universe, can we ever step outside of that universe to find some final, static, ultimate truth?
Relying on Gödel's and completeness theorems, the source concludes that the answer is a hard no. Because of eternal emergence, the universe is never a closed, static system. It is constantly generating new rules on completely new emergent levels. Therefore, our pursuit of knowledge, truth, and wisdom, which the text refers to as WWW, is an infinite asymptote. Absolute truth literally expands alongside the universe itself. We can definitely get closer and closer to it, but we can never fully enclose it in one final, finished equation. And that perfectly tees up the final takeaway from this incredible source material. Because the truth is, this ever-expanding asymptote, the only real defense we have against self-deception and systemic stagnation, is to adopt a really radical practice. Strong opinions loosely held. It means you've got to formulate your ideas ruthlessly and sharply so they can actually be tested in the real world. But you absolutely must separate your personal identity from those ideas. You have to be ready to drop them the very second a hard contradiction shatters them. It's a super powerful, provocative thought to leave you with today. Keep seeking the truth, keep embracing that friction, and we'll see you in the next explainer.